Hi there and welcome to another video, this one on NCEA Level 2 Achievement Standard 2.2 Drawing Graphs. We're going to start off with a basic y equals x squared graph here, and this is of the form y equals a into x minus b all squared plus c. And we're going to look at what each of those things do, what the a does and what the b does and what the c does. At the moment, the graph that we have drawn there is the standard y equals x squared. You can see it is a U shape, so it's of the shape of a U, and you can see, like, if I go across here, if I go across 1, I go up 1, so it's a 1, 1. If I go across 2, then I go up 4, because 2 squared is 4, and we're doing a squared graph here. So if I go across, all the way across to there, if I go across 3 units, I'm going to go all the way up 9 units, because 3 squared is 9. Right, that's going to become useful later, especially when we're looking at how to figure out this a value here. Right, at the moment that's just a standard y equals x squared graph, so let's have a look what happens when we start moving these things. So if I go and actually start typing in, go back to here. Now let's have a look if I actually draw a different type of graph. If I actually want to move it, say, to the right. So if I'm going to move this to the right, I'll go minus 3 in there, and let's have a look at what happens here. Right, that minus 3, so again, this is then y equals x, a little bit messy there, minus 3 squared. Now what's happened is that it has moved across here 3 units. So the 3 on the equation actually moves it to the right. So it's minus 3, so it has actually meant that basically your axis has moved minus 3 to the left. So the whole graph has actually moved to the right 3 units. Alright, let's have a look at doing another graph. How about if we actually do, I don't know, something like plus 1. And let's see what that actually does. That there has moved it to the left 1 space. So if I've got, just get my pen here, if I've got y equals x plus 1 squared, this bit here moves it to the left. Okay, so how do we actually move things up and down? So let's have a look at what if I do something on the end there, something like plus 3, and let's see what happens here. See, moving the plus 3 has actually moved it up 3 units. So y equals bracket x, this is x plus 1, because it moved to the left 1, plus 3 actually moved it up. So this bit here moves it up, and this bit here moves it to the left. Okay, so we've now got the transformation of how you move it left and right, how you move it up. Of course, if you move it down, we're just going to have a minus on the end. So say something like, I don't know, minus 5. We'll take it all the way down to minus 5 and see what that looks like. Right. Let's get my pen back. Right, so this here is y equals bracket x plus 1, because we still moved it to the left 1, squared, minus 5. So that bit there moved it down. That one there, again, moved it to the left. Right, so we've moved it up and down, we've moved it left and right. Now, the next thing that we can do is if there is a number in the front here. So now we're going to try something about having a look at what happens when we put a number in the front there. Right, if we put a number in the front there, I don't know, something like a 2. You can see it's become a lot more squished up. In other words, the gradient has actually increased. So this here, this equation of this is y equals 2 bracket x plus 1 all squared minus 5. So that number there actually changed the gradient. It actually made it steeper. Right, what else did it actually do? Well, if you actually look across here, how does it make it steeper? Well, it goes across 1. We expect it to go up 1 with a normal one, but it's actually gone all the way up to 2, twice as big. And again, from the vertex, if we go across here, if we go across 2, we expect it to go up 4. But we've actually gone all the way up here, we've actually gone up 8. It is twice as much as what we expected. So we can always actually work out what the gradient is, and that is the actual over what you expected it to be. And that there is the gradient, the change in the gradient. Right, so let's have a look at another one. How about I do something like this, make that a 3, make this one a minus 2, and this one we'll just make that a plus 1. Okay, so now we've got another graph here. Lots of different things have gone on here. Right, so this graph has actually moved up 1. So it is going to be a y equals, remember you got something in the front there, already know because you've seen it, but we'll calculate that. And then this is x, it's moved to the right. So if it's moved to the right, that's minus 2 squared. It's moved up 1, so this is a plus 1. And what we're going to look now here is what the gradient has done. If you go across 1, we expected it to go up 1. Okay, so the expected that we expected it to go is actually 1 is what we expected. What did we actually get? We went up 1, 2, 3, but we actually went up 3. So the actual is 3. Therefore the gradient is 3 over 1. So therefore the number in the front here is, what's my pen working now? The number in the front there is actually 3. Right. Try that again, see what's going on with my pen. Oh, we've just had a little bit of a crash with that. But anyway, you get the general idea. Thank you.